Hello. In this video, we have a review question. So as ACE Physics students begin to complete their coursework, they'll start to review all of the previous chapters and learning objectives. This is a worked example question related to the learning outcome belonging to the concept of dynamics. The learning outcome was solve problems using F equals ma, Newton's second law. So I'll go through question 10 first, which relates to that particular learning objective, and then move on to question 11, which also is a dynamics question, but it's specific to perhaps a different learning objective. This is from ACE Physics Syllabus Code 9702. This is paper 12 from October-November 2017. Question 10 reads, two blocks of masses capital M and lowercase m are joined by a thin string which passes over a frictionless pulley as shown. The acceleration of free fall is g. What is the acceleration a of the two blocks? So it's about solving problems using Newton's second law, which says that F equals ma. But maybe it's more useful to think about that as like the sum of the forces, or like the net force is equal to mass times acceleration. Because we have a pulley here and capital M is more massive than lowercase m, they kind of shown us, well, it's going to sort of accelerate this way while this one's being pulled up. And so this acceleration is the same as that. I kind of like to think about it right here. So I'd say like, well, that direction there is positive. I always would make the direction of motion positive. It's my preference, but it sort of doesn't matter. All right, so we need to add these forces. What are the forces that we can sort of identify here? Well, weight, right? And so we have to remember that weight is the force due to gravity, and it's equal to mass times the acceleration of free fall. And so we'll have the weight from this mass. So on the left side of the equation, we're going to add the forces. So we have this direction is positive, so I'll say m times g, okay? And then opposing that, right, because the weight of this is acting down this way. The weight here is acting down. And so while the weight acts in the same direction, remember that sort of our axis of motion is sort of in this direction. And so this vector here, this weight vector, opposes sort of that direction. It's opposing the weight vector here, right? Because this is sort of our direction, right? And so because our direction of motion is this way, this mass is moving in that same direction. This mass is being sort of pulled against it. And so these weights oppose each other. Even though they're both acting down because they're suspended over a pulley, these two weights, capital Mg and lowercase mg, right, are in opposite directions, and so we subtract those weight vectors, those forces. And then let's continue sort of thinking about this. Well, this is all the mass that's going to be accelerated, right? And so here, this will give us the net force, but both of these masses are going to be accelerated, right? This one is being accelerated at acceleration a, all at the same time that this mass is being accelerated at acceleration a. And so we have to think about sort of this side of the equation here now as the combined masses, right? Both of those masses, lowercase m plus capital M, are accelerating, right? And so we need to solve for that acceleration. Here I've basically sort of laid out the equation that'll get us to the correct answer. The rest is just a little bit of algebra. And so because we want to know the acceleration, we're going to divide by this term, m plus m. All right, factor out the common term g there, and we'd have in the numerator capital M minus lowercase m, times g over m plus m, and that's equal to a. So what is the acceleration a of the two blocks? It's the difference of the masses over the sum of the masses times g, which is choice B. Moving right along to question 11 here, this is also sort of belongs to the big idea of dynamics, but it more relates to the learning objective, identify the forces acting on a body in different situations. And so we just have to remember that up thrust is a force, right? So there's different forces that we need to sort of be able to identify and sort of be able to recognize and provide an explanation for. So let's read through the question. It says, the diagram shows a block of copper suspended in water. Okay. The block experiences an upthrust from the water. Which statement is the basis of an explanation for this upthrust? So basically what we have here is that the deeper down we go in this water, the higher the pressure is going to be, okay? And the sort of source of this upthrust is all of the particles that are sort of crashing into sort of this side of the object. There will be more collisions and therefore a greater force sort of underneath it than sort of on this side of it where the pressure isn't as big. The equation that we usually use to sort of think about this is pressure equals density times gravity times height. And so we have to kind of think about, well, the density here is going to be the thing that is constant, okay? But the pressure is going to increase with depth, right? Because there's more water sort of above face R, the pressure is going to be greater down here. Well, what is pressure? Pressure is the force per area. And so even if face S and face R were the same area, there would still be a greater sort of force down here because it's at that greater depth, right? Because there's more water sort of above face R down here than there is above face S, then we know that the pressure must be greater down here at face R. And so the pressure of water increases with depth via this equation is the correct explanation for the upthrust, that force that's really due to all the collisions of these particles, the water molecules crashing into this block of copper.